Alright guys, welcome back. Day 2 on figuring out solution outcomes to linear equations. Yesterday we did it by looking at what you get from solving the equation. Today we're going to look at shortcuts. How can we figure out how many solutions there will be without solving? So we do that by looking at the structure of the equation, specifically the structure of the expressions. So we're solving. So again, the point is to know how many values of the unknown that can make the statement true. That actually will make one expression equal to the other expression. And just to review, when we have linear equations, which are the types of equations that we've been doing, there are 3 possible solution outcomes. There will be one solution, there will be no solution, and there will be infinitely many solutions. This means that there's one number that can make the 2 expressions equal. This means that there are no numbers that can make both equal, and this means that all numbers can be plugged in and make both expressions equal. So, this is one that we worked on yesterday. We saw that it has one solution when we solved it. And the reason we could tell is that when we finished it, we had a variable equal to a number. Or another way we could write that is x equals a. Your variable is equal to some number. But let's see what we can see to figure that out without solving. And so what I'm going to look at here are the coefficients. We've got different coefficients. We have a 5 and a 3. And in fact, that alone is all the information you need to guarantee that an equation will have one solution. As long as they have different coefficients between the 2 expressions, then you are guaranteed to have one solution. There will be an answer. There is a number for x that can make this expression equal to the other expression. And maybe that x value is 0. Remember, 0, if you have x equals 0, that still means one solution. So instead of solving, we can just look at the coefficients. Are they different? 5 and 3 are different. This will have one solution. Let's look at this case here. When we did this, we saw that there would be no solutions. We could tell that because when we solved it, we had 4 equals 5, or we had a number equal to a different number. We can write that as a equals b, 2 different numbers equal to each other. So just reviewing some of the solving steps at the same time. Now, how could we figure out it had no solutions without solving? So I'm going to look at the coefficients again. This time we had a 6 and a 6. So we have, in this case, we have the same coefficients. Well, maybe that's enough. For one solution it was different. For no solution it's the same. However, let's look at that third case. And here was a case when we had infinitely many solutions. And we could tell because in this case we had 7 equals 7 is what we got, which means we had a number equal to itself. In our notes we wrote a equals a, a number equal to itself. Well, in this case, when I look at the coefficients, we have 2 and 2. This also has same coefficients. So one solution had different coefficients, but no solutions had same coefficients, and infinitely many solutions had same coefficients. So how can we tell apart the no solution from the infinitely many solution? And what we're going to do there, we're going to switch over to look at the constants. And the constants in this case, we have a 4 and we have a 5, which are different values. And that's the important part. They'll have different constants with no solutions. So if you think about it, no matter what number you pick, when that number is multiplied by 6 and then you add 4 to it, it's never going to be the same as if you multiply 6 and add 5 to it. This side here will always be 1 more than the other side because 5 is 1 more than 4. So they're never going to line up. They're never going to be the same value. When you plug in any number, this side will always have 1 more. So there's no solutions. Same coefficients, different constants. Whereas the no solution, or excuse me, the infinitely many solution, then I look at the constants, I have 7 and 7, positive 7 and positive 7. So in this case, we actually ended up with the same constants. You can multiply a number times 2 and add 7. That's always going to be the same or equal to the number times 2 plus 7. You're doing the exact same thing on both sides, so of course the numbers are going to be the same. And so these are the structural clues we look for. We start by looking at the coefficients. If they are different, you've got one solution, done. But if your coefficients are the same, then it could be no solutions or it could be infinitely many. So if you have the same coefficients, you need to look at the constants. Different constants would be no solutions. Same coefficients and same constants would be infinitely many solutions. So take out your toolkit. This is page 22. If you don't have it out already, take it out now. Pause the video if you need to make sure all the kids have their toolkits out and on page 22. Okay. So we filled in this last column yesterday. If it's one solution, you have x equal to a number. If it's no solution, you had a number equal to a different number. If it's infinitely many solutions, you've got a number equal to itself. Today we're focused on how to tell by structure. If there's one solution, they will have different variable coefficients. If it's no solution, they will have same coefficients. Infinitely many solutions will also have same coefficients. So you start by looking at the coefficients. If they're different, boom, one solution. If they're the same, well, now you got two choices. And the only other things we can look at to examine are the constants. No solution will have same coefficients but different constants. Infinitely many solutions will have same variable and same constants. So that's how we can tell by looking at the structure of the equations. And just remember, these clues are when both expressions of the equation are simplified. So make sure you always are looking at two simplified expressions. Okay? Otherwise, these clues don't work. You have to be looking at the simplified expressions. Okay. This is the one from yesterday. Hopefully you finished that. If not, what I'd like you to do is start with the one for today, and if you're finished with the one for today where you're solving by structure, go back and do the one by just solving. Okay, get your practice done. Tomorrow we are going to take a quiz on how we're doing on the number of solutions as well as solving with variables on both sides. So if you want to go back and practice what we did on Monday and Tuesday after these two are done, you can to prepare for it. All right, I will see you guys tomorrow. Bye.